The Math Center presents Compound Probability using OR. In this presentation, we'll talk about calculating probabilities involving selection of playing cards using the conjunctive OR. We'll also calculate probabilities involving the selection of objects using the OR conjunctive. Finally, we'll talk about calculating probabilities using that conjunctive OR in a data table. Let's start with a few definitions and guidelines. The word OR in probability means to add. We will want to add the probabilities of the two or more events you are considering. If the events are overlapping or are not mutually exclusive, we will have to subtract any commonality. Let's do an example. Suppose Oscar has 12 toy cars in his toy box. 4 cars are green, 5 are blue, and 3 are yellow. If Oscar randomly selects one toy from the box, find the probability that it is either green or blue. In this case, we know that a car cannot be green and blue at the same time. Since we are asked to find the probability of green or blue, we will add the probabilities. If there is no overlap between the groups, then you just add the probability of selecting a green car to the probability of selecting a blue car. There were 4 green cars, so the probability of green is 4 out of 12. There are 5 blue cars, so the probability of a blue car is 5 out of 12. These probabilities have the same denominator, so we add across the top and get 9 out of 12. You can reduce that to 3/4, and that can be made into a percentage or decimal. This says that 75% of the time, Oscar will pick either a blue or green car. Here's another example using playing cards. A single card is selected at random from a regular deck of cards. Find the probability that the card is either a king or a 6. Well, there are 4 kings and 4 sixes in the deck, and an ordinary deck has 52 cards total. First, note that kings cannot be sixes and vice versa, so there are no overlaps between these. We are using OR, so we will add the probabilities. The probability of a king is 4 out of 52, and the probability of a 6 is 4 out of 52. We add them together and we get 8 out of 52. The fraction can be reduced to 2/13, and it can be made into a percentage or a decimal if necessary. This says that when drawing one card from a deck, we will draw a king or a 6 about 15.4% of the time. Let's do another example with a different twist. A single card is selected at random. What is the probability of drawing a king or a club? There are 4 kings in the deck and 13 clubs, but note that there is an overlap here, because the king of clubs satisfies both criteria of being a king or a club. So how do we deal with this overlap? Well, since the king of clubs is counted in kings and also in clubs, we are double counting it. So we will need to subtract the probability once to get an accurate count. The probability of kings is 4 out of 52, and the probability of clubs is 13 out of 52. We add them together to get 17 out of 52. However, we counted the king of clubs twice. We counted it as a king and as a club, so we must subtract 1 out of 52, and we end up with 16 out of 52. That fraction can then be reduced and made into a decimal or a percentage. The answer is that about 30.8% of the time we'll draw either a king or a club. Now we'll consider a data table. This is a data table in which there are female and male nurses and doctors. In this data table, we have 7 female nurses and 3 male nurses for a total of 10 nurses. We have 7 female nurses and 9 female doctors for a total of 16 females. And we have 5 male doctors and 3 male nurses for a grand total of 24 people. Let's examine the problem using this information. We were asked to find the probability that one person selected is a nurse or a male. We have 10 nurses out of 24 people, so the probability of being a nurse is 10 out of 24. There are 8 males total, so the probability of selecting a male from this group is 8 out of 24. There is overlap, though, as you can see in the box here. There were 3 people that were counted in both the male category and the nurse category. So we need to subtract out the overlap by subtracting the probabilities of being both male and a nurse. This is 3 out of 24, so we have 10 24ths plus 8 24ths minus 3 24ths, which gives us 15 24ths. This reduces to 5/8, which is our final answer. In summary, we note that in probability, OR means to add, so we add the probabilities. If the events overlap, we must subtract those which are counted twice. Thank you for watching this presentation on compound probability using OR.